Welcome back. Today we will learn how to insert a node at a given position in a doubly linked list. Now in this situation we say that the user pose is 1. That means user wants the new node here to be inserted in the first position. We have this mnew which is pointing to the node at 102. Now this node is a new node which is to be inserted into the doubly linked list. Now we check this thing that whether the start is equal to null or not. In this situation we can see that the start is null. The meaning of this thing is that the list is absolutely empty. Now when the list is empty, then the new node at 102 will be the first node in the list, right? So you write start equal to mnew. Now mnew means 102, right? So start gets the value 102 and it starts pointing to the node at 102. Now here is another situation where start is not null. That means start is pointing to a node at 743. So that comes with the else part here. Now you see the situation, the start is pointing at 743 and the 743, this node is the first node with the prev pointer null. Of course, the next pointer here is 478 pointing to the next node in the list. And we have also a last node here at 291 with the next pointer null. We also have the new node at 102 which is pointed by the mnew pointer. Now we want this new node to be inserted in the first position in the list. Now if this new node wants to be in the first position, then the prev pointer of the first node at present will point to the new node, right? So you write start prev equal to mnew. Now this mnew is 102, so this prev pointer here will be converted to 102 and it will start pointing to 102 like this. Next you write mnew next equal to start. Mnew next means this pointer. So this pointer will point back to the node at 743, right? So this becomes 743 and it starts pointing to the node at 743. Now there is one more job to be done. That you see that the start pointer is still pointing to the node at 743, which is second node now. And the node at 102 is the first node now. So, start pointer should point to the node at 102. So you write start equal to mnew. So this 743 becomes 102, the link vanishes and the new link is established here. So you see that the start is pointing to the node at 102, the node at 102 has become the first node and this node that was first node before, now it has become the second node the second node has become third node and fourth node and fifth node eventually, right? Now, let us consider another situation where the user wants the new node to be inserted in the third position, which is here. So, if this new node at 102 is to be inserted in the third position, then it will be inserted somewhere here so that this new node becomes the third node, and the third node at present will become the fourth node, and the fourth node at present will become the fifth node, right? So let us see how we can do it. We take the help of the temp pointer now. So let us set the temp pointer to the first node with the help of this line, temp equal to star. So temp becomes 743 and it starts pointing to the node at 743, which is the first node, right? Next you write temp pose equal to 1. Why? Because we have to keep track of the temp's position in the list. Now, since temp is pointing to 743, which is the first node in the list, then the temp pose, that is the position of the temp, is 1. So, we take a variable temp pose which is carrying the value 1 here. Next, we write while temp pose is not equal to user pose. Why? Because our plan is to take the temp to that position where the user wants to insert the new node. Now, for this specific case, the user wants to insert the node at the third position. So, we want our temp to stand at the third position here. So we have to take the temp from the first node to that position provided by the user, right? So every time the temp is positioned over a node in the list, we match whether that temp pose is equivalent to the user pose or not. Now, if it does not match, then we will move temp pointer further. And again, we will check whether the new position of the temp is matching with the user's position or not. So this while loop will run until the temp pose is equal to user pose. Okay? So we have user pose equal to 3 and temp pose equal to 1 at present. Now what we see is not matching. Since it is not matching, then we run the while loop and we write the code inside that temp equal to temp next. Now what is temp next? Temp next is 478. That means this one. So we want the temp to point to this 478. So it goes like this, right? Now we should not forget to increase the temp pose because temp has moved to the next node from where it was before. So temp pose equal to temp pose plus 1. Right? So temp pose is now 2. Then we move back and check whether the temp pose is equal to user pose or not. And what we see? The temp pose is 2 and user pose is 3. That means it's not matching. Then we get inside and execute this statement temp equal to temp next. Now temp is standing at 478 and the temp next is 521, right? So temp will be 521 now. And it starts pointing to 521. Next, we execute temp pose equal to temp pose plus 1. Now temp pose is 2. Now it becomes 3. Now what do you see? Temp pose and user pose is matching. That means we stop the loop. So we have got temp on that position where the user wants to insert the new node. Now we have to go for the adjustments of the pointers. Okay. We write temp prev next equal to mnew. Now what is the meaning of this? Now temp is at 521 and the temp prev is 478. You can see that. Now the next pointer of the node at 478 will be loaded with mnew, that is 102. Now why we are doing like this? Because we want the new node to be inserted here. That means this pointer, which is pointing to the next node at 521, should point to 102. Right? So this becomes 102 now, and this link breaks and this link is established. Got it? Now, since this is a doubly linked list, so the new node at 102 will point back to the node at 478. So at present, the 102's prev is null. So it should point to the 478 back, right? So you write mnew prev equal to temp prev. Now this temp prev is 478. You can see that. So mnew's prev has got 478. So the null is replaced with 478 and the pointer starts pointing to 478. Now what about the next pointer of mnew? This one. This should point to the node at 521. Right? So you write mnew next equal to temp. Now temp means 521. So null will be replaced with 521 here and it will start pointing to 521 like this. Now look at the node at 521. That is the temp. The temp's prev is still pointing to 478, which it should not. It should point to mnew at 102, right? So you write temp prev equal to mnew. So this 478 will be replaced with 102 and this link breaks and this link is established. So you can clearly see that after this second node at 478, this new node at 102 has been inserted properly so that the next pointer of 478 is to 102. And of course, 102 is pointing back to 478. On the other side, you can see that the node at 102 is pointing to 521 and the node at 521 is pointing back to 102. That means your new node has been inserted properly in the third position. So we can write this one as third position. This third position will become fourth position and the fourth one has become fifth position. So I hope it's clear to you that how to insert a node in a W-linked list. In the next video, we will learn how to delete a node at the first position in a W-linked list. Thank you for watching and take care.